In lesson 12, we're going to graph transformation of parent functions, and we're going to show you a neat way to do this. It's amazing to me that every little piece of mathematics connects to the order of operations, and we can tie transformations of parent functions back to the order of operations. I don't know if you've seen this exactly like this. You actually understand that it can shift up or shift down or shift left or shift right or get steeper and less steep and some of that. We're going to look at it as a transformation of the parent function points. I don't know that you've seen it like that. But before we do that, what I want to do is show you the basic graph of each type of parent function that we might deal with. So I'm just going to wipe that out. You can write this on the back bottom page of your handout or on a notebook paper or something. But I just want to kind of explain to you my layman's way of explaining why things come out looking like they look like as far as basic graphs. This is the what. Y equal x is the what. It is the parent function of a what. It's the parent function of a line. And what does the graph look like? If we drew the xy axis, it would do what? Bisect quadrants 1 and 3. So we should know from Algebra 1 and up that y equal x is the parent function of a line, and it bisects quadrants 1 and 3. So if we added something to it, it would shift up. Subtracted something from it, it would shift down. If we increased the slope, it would get steeper. Decrease the slope, it would get less steep. Lines with positive slopes lean to the right. Lines with negative slopes lean to the left. If the slope is 0, it's horizontal. If the slope is undefined, it's vertical. We should know every bit of that stuff from our experience with linear equations, okay? If you didn't understand everything I just said, you can rewind and watch it again, or listen again. All right, now, if we had y equal x squared, that is a quadratic. And the parent function of a quadratic looks something like this, where the y-axis is the line of symmetry. This should be symmetrical. And the origin is the vertex. Remember that? It opens up because A is positive and all those things you've talked about. The vertex is a minimum. A is positive, so it opens up. We'll discuss that some more in another lesson. Notice this. Well, I'll wait a second. Let's say that we had y is equal to the square root of x. This is a square root graph. And it's going to look something like this. Can somebody tell me why it doesn't go down? And why it doesn't go to the left of the y-axis? Because the coordinate plane represents the set of all real numbers, and we cannot have a square root of a negative, right? So if you plugged in a negative for x, it would be undefined for y. You'd get an imaginary number, which wouldn't fit on the coordinate plane, you see. So when you do square root instead of square, half of it disappears because the square root of a negative is an imaginary number. All right. Now, what if we had an x squared plus y squared equal 1? You know what that is? It's a circle with radius 1. That should have been a circle with radius 1. I just want to show you something kind of neat here. For every 1y, there's 1x. Notice that. For every 1y, there is 2 x's. If I go up such and such, there's 2 x's. If I go up a different amount, there's 2 x's. If I go up more, there's two x's. Notice how the exponents just kind of make that jump out there. For every x, there's two y's, and for every y, there's two x's. I just kind of like the looks of that. This kind of does something. Anyway, so here's some basic parent function stuff. And then remember we said, okay, if you take that line and add 2, what happens? Shifts or translates up to, remember that? And we said if you add 2 to the quadratic, what happens? It shifts or translates up to also. So the same thing happens to a quadratic that happens to a line. But then we went from that into graphing form. We said we had y equal a times x minus h quantity squared plus k, the graphing form of a quadratic. Remember that? And what we said was, this is important. This is where we got to get to. I want you to write that down because we're going to talk about it. Yes. What is on the outside of those parentheses is going to happen to the y in the order of operations. According to doing. I know that sounds goofy, but this is for real. What happens to the graph? What happens to the y of the parent function point is what's going on the outside of that parentheses. And it's going to happen to the y of the parent function point in the order of operations according to doing. You're going to see what I'm talking about in a minute. What is on the inside, and I could even put I could put another letter in here. If I put a B right there, then what's on the inside happens to x in the reverse order of operations according to undoing. Okay? So once we get in graphing form, and we have that parenthesis, then we can say that what's happening to the y of the parent function is what's outside of the parenthesis, and it happens in the order of operations according to doing. And what is on the inside of the parentheses is going to happen to the x of the parent function point in the reverse order of operations according to undoing. And that's fixing to make sense. All right, any questions on that? That's what I needed you to know first. I'll give you time to write it down, think about it, and then we'll go into problem number 1 and we'll watch this come alive. It's really intriguing. I like this. This is neat. Everybody ready to go? Okay. Okay. The parent function. The parent function of this is really y equal x, isn't it? Notice when we graphed, remember, the parent function of a line, we started out with the old faithful points. I'll call them -2, -1, 0, 1, 2. And when we plug what y is equal to in the middle, then we would choose those x's and plug them in to get the y's that go with it. And so we would get -2, -1, 0, 1, 2. That is our normal parent function points for a line, okay? That's our normal parent function points for our line. Now what we're trying to do, just so you know, is we're trying to say the parent function had a point at negative 2, 2. Where's that point going to end up at? The parent function had a point at negative 1, 1. Where's that point going to end up at? See, we're not just looking at where does the graph end up at. We're looking at where do these points end up at. And if I could figure out where all those points ended up, I could find out where my new graph ended up, you see. So we're going to move all the parent function points and find out where the graph ends. That makes sense? Okay, so let's think about this. If we had the parenthesis here, this would actually look like y is equal to 2, open parenthesis, x plus 0, close, plus 1. Is everybody okay with the fact that those are the same thing? Okay, so in reality, what's happening to x? What are we going to do to x? There's an understood 1 and an understood 0. What's going to happen to x is what is on the inside of the parenthesis, and it's going to happen in the reverse order of operations. So we would have to undo multiplication and addition, and we would have to undo addition by subtraction first, and then undo multiplication by division second. So what's going to happen to my x is I'm going to subtract 0 and divide by 1. Now, if I were to take negative 2 and subtract 0 and add 1 and divide by 1, I would get negative 2 minus 0 is negative 2 divided by 1 is negative 2. In other words, nothing changes when you subtract 0 and divide by 1. You understand that? But I would subtract 0 and divide by 1 and still have negative 1. Subtract 0 and divide by 1 and I still have 0. Subtract 0 and divide by 1 and I still have 1. Subtract 0 and divide by 1 and I still have 2. So the x's of my new points ended up exactly where they were before. But I figured out where the x's of my parent functions ended up when you translate that parent function point. We also want to know, where did the y of this point go to? Where did it end up? Well, what happens to y is what is outside the parenthesis, and it happens according to the order of operations. Now, you realize we have multiplication and addition, and according to the order of operations, you would do multiplication first, and then you would add second. And so what's going to happen to my y is I'm going to multiply by 2 and add 1. Now, you understand, I'm going to take my old y's. This was my old y's, right? And I'm going to say, where do these things end up? Where does the negative 2 end up? And the negative 1 end up? And the 0 and the 1 and the 2 end up? So, if I do negative 2 times 2 plus 1, I get negative 4 plus 1 is negative 3. So that point that started out at negative 2, negative 2 is going to end up at negative 2, negative 3. That's where it's going to end up, that point. This y is going to be multiplied by 2 and added 1. Negative 2 times 2 is negative 1 times 2 is negative 2 plus 1 is negative 1. So that point ends up at negative 1, negative 1. The y is going to change by multiplying by 2 and adding 1, and so we're going to get a 1. So that point ends up at 0, 1. What's happening to the y is we're multiplying by 2 and adding 1. 1 times 2 is 2 plus 1 is 3, so this point ends up at 1, 3. What's happening to the y's? We're multiplying by 2 and adding 1, so that ends up at 2, 5. I'll try to backtrack. Let me let you catch up, and I'll try to highlight, because I want to make sure you didn't miss what we just did. And then we're going to graph them and take a look at that, okay? We said, okay, my parent function, my first parent function x was this, and I want to know what's going to happen to that. Well, I'm going to do the opposite of a plus 0, which is a minus 0, and the opposite of a times 1, which is a divide 1. And when I do that, it ends up at negative 2. So this 2 ended up being a negative 2. Then we're going to mess with the y over here. The y of that first parent function point was a negative 2. What's going to happen to it? Well, I'm going to do what's outside in the order of operations. I'm going to multiply by that 2, and then I'm going to add a 1. And so we're going to take that negative 2, multiply by 2, add 1, and get a negative 3. So this point right here is going to end up right here. Okay? And this point is going to end up here. And this point is going to end up here. And this point is going to end up here. And this point is going to end up here. Now we're going to verify that. You see what we did? We figured out where all 5 of those parent function points were going to end up. And we're going to graph our new line by moving all 5 points to their new location. I'm going to move the graph up, and hopefully y'all still have those numbers, okay? So let's look at what happened. I'll do them in different colors. My first parent function point was negative 2, negative 2. Where did it end up? Where did it end up? Negative 2, negative 3. My second parent function point was negative 1, negative 1. Where did it end up? Same place, negative 1, negative 1. The third parent function point was 0, 0. Where did it end up? 0 what? 1. The next parent function point was 1, 1. It ended up at 1, 3. It's kind of looking pretty, isn't it? The next parent function point was at 2, 2. It ended up at 2, 5. My parent function line was here. The new line, y equal 2x plus 1, is right here. Now, we know that if we had y equal 2x plus 1, that it would have shifted up 1 from the parent function. It did. And we know that since we had a 2, that the line would get steeper. And so we could graph that new line by saying, okay, my y-intercept is 1. And then I'm going to do my slope of up to right 1. And you can see that we ended up in the right spot by transforming the parent function points. Isn't that cool how that works with order of operations? Okay, so we verified it was something we already knew. Any questions on number 1? All right. Number 2. Number 2 is a what? Linear, quadratic, exponential, square root. It's got an x square on it. It's got a square. If it's got a square, what is it? It's a quadratic. What's the parent function of a quadratic? Y equal x squared. The graph is a U with its origin. It's vertex, the origin, it opens up, right? Stuff you should know when you come in here. So, we're going to find the parent function points, and we're going to use the old faithful -2, -1, 0, 1, and 2 as the parent function points of a quadratic. So we're going to have -2. You see, we're going to take what y is equal to and put it in the middle. We're going to have -2 quantity squared. Don't forget to put it in parentheses, or it'll give you a sign rule error. Remember that? If you square a negative, you got to put it in parentheses. It's going to pop out a +4, not a -4. -1 in parentheses square, +1. 0 square, 0. 1 square, 1. 2 square, 2. 4. 2 square, 4. Whoops. Got on a roll there, didn't I? Now, you see what we're doing? We're going to say, okay, this is what I started out with. Here's my old x's. I want to see where they end up. And here's my old y's. I want to see where they end up. So I'm going to put those y's over here. 4, 1, 0, 1, 4. I want to see where my old xy's end up. Now I'm doing my x's and then doing my y's, but you see, I'm really wanting to see what this turns into when we get all the way over here, right? Are y'all understanding that? I want to know where this point -2, 4 ends up when I get all the way over here. So I'm going to see where the x ends up, and then I'm going to see where the y ends up, and then I'm going to put them together to say, here's where the thing ended up, okay? Now, let's look at our rules. What is happening to x? What is happening to x is what is inside the parenthesis in the reverse order of operations. Now, what's in there is an understood 1 that's being multiplied and an understood and a 1 that's being added. Now we do it in the inverse order of operations according to undoing. Which one of those two, multiplication or addition, would you undo first? Undo addition. And what would undo addition? So the first thing we would do is subtract 1. And then we would undo the multiplication by division, and we would divide by 1. So to figure out where the x of that parent function point ends up, you're going to do what's inside in the inverse order of operations according to the rules of undoing. So we're going to say -2 minus 1 is -3, and -3 divided by 1 is -3. See that? -1 minus 1 is -2, and -2 divided by 1 is -2. 0 divided by, or 0 minus 1 is -1, and -1 divided by 1 is -1. So we've got -1 divide 1, -1 minus 1 divide 1. 0 minus 1 is -1, divide 1 is -1. 1 minus 1 is 0, divide 1. What's 0 divide 1? 0, not under, because the 0 is on top, it's 0. 2 minus 1 is 1, divide 1 is 1. So my x's ended up at -3, -2, -1, 0, 1. These 5 parent function x's ended up being that. Now we want to see what the y's of those 5 points ended up being. Somebody see what we're doing now? If we want to see what happens to y, we look outside the parenthesis. My operations are multiplication and addition. What happens to y happens in the original order of operations according to doing, not undoing. Which one would you do first, multiplication or addition? Multiplication. So we would multiply by -2, and then we would do the addition of 3. What happens to y happens in the order of operations according to doing, and it's the stuff outside the parenthesis. So we're going to have 4 times negative 2 is negative 8 plus 3 is negative 5. 1 times negative 2 is negative 2 plus 5 is 3. 0 times negative 2 is 0 plus 5 is 5. 1 times negative 2 is negative 2 plus 5 is 3. That's a 3. Uh-oh, thank you. Reverse that. We'll start again. 4 times negative 2 is negative 8 plus 3 is, see where the 5 came from? We got the answer before the question. Anyway, 1 times negative 2 is negative 2 plus 3 is 1. 0 times negative 2 is negative 2 plus 3 is, 0 times negative 2 is 0 plus 3 is 3. 1 times negative 2 is negative 2 plus 3 is 1. And 4 times negative 2 is negative 8 plus 3 is negative 5. And this top answer is also negative 5, correct? That's a negative 5 up there. 4 times negative 2 is negative 8 plus 3 is negative 5. Those have to be the same. That's why I paused for a second. I knew it messed up. Because we're talking about a parabola. We got to have reflecting points. I knew I didn't get a reflecting point. Something's messed up somewhere. And so the parent function y's end up at negative 5, 1, 3, 1, negative 5. Now what we're going to do is graph the parent function, graph the new one, and then we're going to talk about the way you learned this the first time and see if what you thought was going to happen really did happen as we do it by transforming each point. We're going to move each point rather than building a whole new table and looking at the parameter changes as you talked about before. Is everybody caught up there? So let's do these one at a time just so you can see. Okay? Y'all got them written down. The first parent function point was where? Where was the first parent function point? Negative 2, 4. Are y'all with me now? Negative 2, 4. Where did it end up? At negative 3, 5. Oh, at negative 3, negative 5. That was a crazy move, wasn't it? That point went from there to there. The second parent function point was at negative 1, 1. It ended up where? Negative 2, 1. Cool, huh? The third parent function point started at, and it ended up where? Negative 1, 3. The next parent function point started at 1, 1, and it ended up at 0, 1. The next parent function point started at 2, 4, and it ended up at 1, negative 5. So here's the parent function. And here is the new function. Now the equation of the new function was y equal what? What was our new equation? Okay, let's talk about what you learned in algebra before, because we're going to do this again in another lesson. We talked about what would happen to this parent function if I added 3. What would happen? It would shift up 3. Right? What would happen if I had a minus 1 in there? It would do the opposite of a plus 1, which is a minus 1, which means it would shift. What's the negative direction for x? To the left. Y'all listen to this. This is important. You see, what happens inside is happening to x, but it's happening according to undoing. You didn't really maybe learn it happened according to undoing. It'd say, well, if it's a plus, it does the opposite of minus. Or if it's a minus, it does the opposite of plus. It's a plus 1, so it's going to do the opposite minus 1. It shifts over there, right? So now it's right here. See that? And then, what happens when we make that a 2? It gets steeper. The wings fold in. Remember that? What happens if your A is positive? It opens up. But what happens if A is negative? It opens down. You see, it went where it was supposed to according to the way we learned it before. But instead of thinking, okay, it shifted up 3, shifted left 1, it's going to get a little bit narrower because of the 2, and it's going to reflect down. It's going to open down. We still wouldn't know exactly where it was. We'd just know about where it was. But if we transform the parent function points, we know exactly where it is, you see. Not just about where it is. All right, any questions on what we've done? We still ended up in the right place. Are you kind of seeing why then what happens to y actually happens according to doing? It actually did go up 3. And what's happening to x is actually happening according to undoing. It did the opposite of a plus 1 or to the right 1, and it went a minus 1 or to the left 1. So that verifies the idea of the order of operations as we transform those parent function points. Okay? Any questions there? I think we'll stop with that. That gives you some time to reflect, and we'll record more of this in another lesson. That's a good bit of stuff to try to soak in one day. Appreciate your attention.